So to start things off, we can't use our main stream to make this animation because the name attribute exists differently for each individual piece. Instead, we ought to bring in all the pieces before they got fractured. So that is the first step. Object merge, and we are going to bring in the primary stream right there. Okay, once we have that, use an assemble and create packed geometry. That way we just have 46 packed islands. Let's also create a grid because this is going to be the thing that collides against these islands. So I'll make it slightly bigger than the pieces themselves. I'll bring it down. Go here to create a absolute channel reference to the rows, and then maybe about 50 or 45 is just about fine. We don't have to go too crazy on the resolution here. Use a mountain sop, turn the height up, element size up as well. Noise type, I'll do the Whirly Cellular F1, $T on time. And if we press play, we end up with that. Let's template this island though, and I want to now keyframe this movement. So let's go ahead and turn up the height a bit more, like that. I'll also go ahead and set down a transform sop. And don't go too far below this right here because then the velocity will be too much. But we basically just want to take our plane, keyframe, let's say right there around frame 1, and then have it go up maybe right about there and set another keyframe. So now we end up with that. Also, I'm going to slow down that approach because, again, I don't want the velocity to be too crazy on this. I would say even less than that. So we'll do that. Shift middle mouse, spacebar F. I'm going to straighten these tangents out by clicking that. And now we end up with that. Okay, awesome. From here, I want to collide against some spheres because that's really fast for Bolt to calculate. So I'll use copy to points. And if you don't know this trick, it's pretty cool. We just have the points over here on the grid, and we create a sphere right here to copy over. And then we just turn down that uniform scale until we're roughly covering everything like you see. Let's also create a dop nets, and we can take our collision spheres, put it in the second inputs, and use our plates for the first inputs. In here, let's create a rigid body solver and 2 RBD packed objects. So we'll go this guy for the islands and this guy for the colliz spheres. Merge those two together. Whoops. Doing that. There we go. Okay, islands will be first context geometry. Colliz spheres will be the second. For the first context geometry, you always want to check what these are doing. I think this is fine for the most part. It might be worth a convex decomposition. Probably not, though. We're just trying to get the overall movement, so I think this is fine for what we need. And then over on the colliz spheres, let's check this as well. So we want to create deforming static objects for one. Let's turn off the display geometry, go to bullet data, show guide geometry, and as you can see by default, it's doing just fine. So we actually don't have to worry about anything there. Okay, so now that we have our spheres, our islands, we go forward a little bit, and as no surprise, these plates should fly up in the air. So it looks like it's approaching a little bit too slowly. I don't like what it's doing there in the center because that's going to give us some issues. So let's go ahead and go back here and adjust our keyframes a little bit. So we'll take the transform, we'll bring it in a little bit closer, and then also on this noise, I'll take down the height a tad bit and turn up the element size. So now, if we go forward, we should have a very different effect. And there we go. Now we end up with something like that. So suppose that this is looking the way that you'd like it to. We might need to do some fine tuning and things like that, but for right now, let's say that that's good. Dop imports, drag that over. We want to create points that represent the objects, only include anything that says plane on it, or I guess the islands, that's what we called it. So anything that says islands, like so. And now we just have these guys. But be careful, because whenever you do this create points to represent objects, you'll get this popping at the very beginning. And that is because I found you need to check on this solve on creation frame. So if you do that for both of these guys, that'll fix the popping issue. Just a good thing to know. It's a sneaky little default that's bound to mess you up. So watch out for that. Okay, so we go forward a few frames, and now we can use the transformed pieces. So let's say transform pieces. Here are the points. The pieces we want are up here. We'll also unpack them because that makes it faster. So we'll unpack that. That seems to be working just fine, but now we have to get rid of the position data so that we only have rotation left over. So to do that, let's create a time shift, delete that, frame 1, and also a point wrangle. For the point wrangle, we want to take a look at the position of that frozen time shift, of the pieces frozen in time. And we want to use the position data on that and just leave the rotation data alone. So start off by creating a variable that's a vector called new pos is equal to the point function, looking at input 1, which is the second input on our node. Call this, or look for the attribute called p, and then use ptnum to reference each point. Once we have that, our new position is equal to new pos. And by doing this, now we are only left with the rotations, which is great. Okay, so the rotations are pretty cool, but at a certain point, they become way too intense. I mean, if we go out to, let's say, frame 70 or something like that, these plates have gone way too far, and we want to stop the rotation at a certain point. So there's a few things we can do to achieve that. One thing is we can go up to the DOP.NET and we can create some drags. That'll help. So create a pop drag and a pop drag spin. So these guys, I'll set the drag to 0.1, drag spin to, let's say, 0.2, something that's a little bit heavy. There's a merge. We'll put that in the post solve. And now, if we resim this, that should help. We're also going to use the assistance, though, of a time warp. And so let's go forward a few frames, see what it looks like first, and then we'll figure out how to warp this. I personally found that when the drag was pretty high, like 0.5 and 0.7, I liked the look of that, and we end up with something right about there. We'll also need to use a time warp, though. So time warp, use this to interpolate between the input frames, and also change this to by speed. For the output and input frame range, let's say that we go all the way to 600 for right now. And for the speed, let's keyframe this so that we're at full speed towards the beginning, maybe like right there. And then once we reach, let's say about this point, we're going to be at a very slow speed of like 0.1, something like that. Now, in order for this to work, though, you have to go down to the point ID attribute and set that to name. That way, it finds the pieces correctly. And after doing so, we end up with something right about there. It's not quite there yet. Let's change this to cubic, and that'll help quite a bit with those in-between frames. But that is the general idea. Also, let's, instead of doing the full speed here at 1, let's just take this all the way down to 25% and see what that does. So let's actually figure out where this even starts. We'll start at 1, actually, and then right before this all begins hitting, we'll quickly switch our keyframe here to 0.25. So that way we know exactly where this starts. And then let's just say we have this. Yeah, now we have a lot more control over this. So instead of 0.25, let's say 0.5. And then maybe we end up with something like that. And just to go even further here in the keyframes, we'll say maybe right about there, and then we'll stop it maybe at 130. So that now we have the full thing like so. Now this isn't perfect. We'll need to really dial this in, and if we want to bring in the temple, we can see what that looks like in the framing. But now at least we have something that will give us the gist of what we're after, and from here, obviously, you can tweak this to your heart's content, but that's the main idea of how we can procedurally do this. It's a really cool way of doing it because now we can just mess around with the collisions and the actual simulation to get this behaving properly. So go ahead and play around with this, see what you come up with, and in the next video, we're going to take this and apply it to the fractured pieces.